Okay, today we're demonstrating the workflow developed to integrate the ARINC 653 block set from MathWorks into PikeOS. So as a brief overview of the workflow, we'll firstly generate CODEO binaries from a Simulink model before creating CODEO configurations, which will ultimately be used to produce a PikeOS image. So we first start in MATLAB. We have an example XML definition of a flight assistance system with a few ARINC 653 partitions and ports connected to each other. From this example file, we can now create a basic Simulink model. The first step is to use the import function to use a MATLAB object, and then within the project folder, we can create the models. So what this will do now is generate one top-level model and a sub-model for each one of the partitions defined in the XML file. So we can see the various models here, and if, for example, we open the top-level model, this model shows the different partitions that have been generated, as you can see here. And if we go inside, we can see it's been set up to call the partition periodically as defined in the XML file, and also the ports are predefined and can be connected to the model. The ports are connected to the partitions based on the port name, so if two partitions have the same port name, that will be collected later on. Because this is a Simulink model, this can also be run in the simulation environment outside of the context of PikeOS. Okay, now to create the PikeOS Apex binaries, we need to configure Simulink to use the PikeOS toolchain, which we do using the apex.config.xml function. And actually here I need to provide to this function the name of the project, or the name of the top model I should say, which is a flight assistance system, and the architecture that we will be deploying to. So in this case we'll be deploying to an ARM v8 based system, so I'll select the ARM v8 PikeOS architecture. What we can see here now is that the PikeOS toolchain is registered, and a number of options are configured to make the models compatible with our toolchain. And now what I can do is run the apex build command to build the system. Okay, we see here that the build is complete, and we can see for the different partitions the generated code. So the top level model doesn't generate code since we build code on a partition by partition basis, but you can see here also the compiled binaries for each partition in the pool folder, which can then be used in CODEO. So we can now switch over to CODEO and create an integration project. Give this project a name. And select here a demo project to start as a basis, but it doesn't matter which one we pick too much, as that will be overwritten by what's imported from Simulink. So I'll select here the BSP and also select the custom pool folder, which was generated earlier in the Simulink environment. And actually, because what we're doing here is an application space integration, this will run on any hardware platform. So for the purposes of the demo, this doesn't matter so much. Okay, we can delete any applications since they'll be replaced with the ARINC 653 applications from Simulink. And what we need to do here before we start the import process is just go into the ticker settings here and just adjust the time partition window duration here to match what's defined for the scheduling in the XML file. Okay, what we could do now is go into our build targets and create an ARINC 653 import build target, which is provided by the integration toolchain, which will allow us to import the XML configuration file into CODEO, which will set up the integration project to match the environment in Simulink. So we have a look in the makefile.defs file here. We'll just check that the XML name is correctly set, which it is, so that's good. Now if I execute the ARINC 653 import target, we'll see the configuration is loaded into the integration project, which will set the partitions up. So each partition is grouped, and you can see that these are also actually available in the custom pool. So each has a partition element, a process which links to the application binary generated by MATLAB Simulink, and a generated configuration which provides information about the ports and setup. So from a system perspective, all of the ports are generated and configured, and if the tool finds matching port names between partitions, the connections or channels, as we call them in this context, are automatically created, and you can see those from these lines from one partition to another connecting a ARINC 653 port together. So in addition, the scheduling scheme has also been imported. In this case, I want to make a small modification to this one because we want two applications to run within the same time partition. So what we want to do here actually is delete one of these time partitions and assign two of them to the same time partition ID. So if I change this time partition ID here, change that to 3, then you see both of these are assigned to the teal color time partition 3 here. Okay, so we're effectively now ready to build the PikeOS image, which includes the Apex binaries generated from the Simulink models. You can see here already that the image has been generated. If I open the boot folder here, you can see the PikeOS image that's ready to deploy to the target.